Hello everyone, I am Sudharshan and in this presentation I would like to convey the key findings of my research done here under the guidance of Prof. Rajesh Sundaresan. The main contribution of my research is a new insight on the policy gradient approach to deterministic optimal control. The goal in an optimal control problem is to find a control U that minimizes the cost function associated with the control and state trajectory that is being controlled to the dynamics as defined. In order to efficiently solve for multiple initial conditions, we consider the optimal policy problem, recalling that the policy dictates the action to be taken at a given state and time. The optimal policy problem aims at finding the policy which induces optimal controls when followed. A key tool to characterizing the utility of a policy is the value function. A value function associated with the policy defines the cost that is to be incurred if the policy is followed from the given state and time. An optimal value function is the value function of the optimal policy, assuming one exists. We are now ready to define a key tool to finding optimal policies, the Hamilton-Jacobi-Bellman equation. The Hamilton-Jacobi-Bellman equation, a partial differential equation, provides a key insight in characterizing and comparing policies. The first and second equations provide necessary and sufficient conditions for the value function of a policy and the optimal value function, while the third provides a sufficient condition for policy improvement. This theorem characterizes in the same spirit as the theorems available in reinforcement learning, where one considers discrete time and space problems with randomness in transition. The policy gradient approach computes the gradient of a control cost J with respect to the parameters theta and performs gradient descent. This gradient can be computed either by backpropagating to the computations of the cost or by solving an ODE as elaborated by the neural ODE theorem. From an optimization perspective, this sounds great, but how does this relate to the policy improvement criteria identified in the previous slide? The answer, as stated by this theorem, is that the policy gradient aims at improving the actions taken by the policy at each visited state time pair, as characterized by the policy improvement criteria in the previous slide. Thank you.